All right, so what you guys were working with last class is what will become the unit circle. So what we started this unit with was a scenario with the amusement park ride where you start here, travel around, and come back to this direction. So this right here is our 0 degrees, and I'm going in degrees first, and then we'll switch to radians. 90 degrees, 180 degrees, should put my degree signs on those, 270, and back around to 360. So if I'm looking at just my 90 degree set, then I need to look at the fraction of the whole circle that I'm working with. So if I go full circle with a radius of 1, and the unit circle has a radius of 1, a full circle is actually, hang on. So one of the things I want to clarify as we move forward is when we're talking about degrees, we're talking about this interior angle. So this angle created by the two purple lines is a 90 degree angle. So this one straight across is our 180 degree angle, that's a straight line. And 270 going around would be referring to this angle right here. So, what portion, or sorry, let's try that again. If I go full circle around, what distance have I traveled? In terms of 2 pi. So all the way around, I've gone around for 2 pi. Half of 2 pi is what? 1 pi. Half of that is what? 1/2 pi, or pi over 2. So I want you to notice something. If I start at 0, this is 1/2 pi, 2/2 pi, so this is going to be 3/2, or 3 pi over 2. That's my 90 degree set. If I split that to my 45, then once again, I'm looking at the fraction of the entire circle. So my degrees, yeah. So I have my 45, 135, 225, and 315? Yeah. So with this set, if I just look at the yellowish-greenish line, that splits my circle into how many equal parts?
6.
If I have...
Oh, just the yellowish green.
Well, actually, let's look at the yellow and the purple.
Okay, 6.
So now I'm split into... How many?
8.
8. So, if I look at this, just the top half, as 1 pi, I have 1, 2, 3, 4 wedges here, right? So to figure out this, my radians for this one, pi over 4, or 1/4 pi, 2/4 pi, the pi over 2 is just reduced, 3/4 pi, or 3 pi over 4, 4/4 pi, what's this one going to be? 5/4 pi over 4, or 5/4 pi. This one would be 6 pi over 4, and this would be 7 pi over 4. Okay, so that's my 45 and my 90 degree set. If I look now at my 30 degree set, and I'm going to go ahead, and you guys have them in 2 different colors. I'm going to make the 30 degree set the same color as the 60 degree set. Partly because the green one that I'm using looks a lot like yellow, so my yellow is kind of useless now. And partly because the 30 and 60 are so very much related.
Can I see your green?
Alright. So, if I look at, so try to disregard the 45. Take the 45 out of this. I don't know what word I'm looking for. Ignore the 45s for the moment. If I look at the 90s and the 30s, I am now split on top into how many equal parts? Thumbs away, guys. So 1, 2, 3, 4, 5, 6 equal parts, right? So this first one, this 30 degrees, what portion of the top is that? What fraction of the top am I looking at? If we're looking just at the top, and I'm looking at 30 degrees, what fraction of the top is 30 degrees? 1/6. So pi over 6. Then I'm going to label my other degrees. So I've got 60 degrees here, 120 here, 150, 180, 210, 240, I already got 270, 300, and 330. So, if I go around my circle knowing that my 30 degree set is 1/3 pi, or pi over 3, so this, sorry, just kidding, pi over 6, 1/6 pi, this is going to be 2/6, which can be reduced to 1/3, so pi over 3, 3/6, 4/6, which can be reduced to 2 pi over 3. So you guys know what I'm going with here. I've got 1/6, 2/6, 3/6, 4/6, 5/6, 6/6, 7/6. That one's not going to reduce. 8/6, 9/6, 10/6, 11/6 is also not going to reduce. So 11 pi over 6. And I'm going to fill in the third. So 1/3, 2/3, 3/3, 4/3, 5/3, and then back up to 6/3, and I somehow missed this one. 1/6, 2/6, 3/6, 4/6, 5/6, so 5 pi over 6. So when you're figuring out radians, you're looking at your total distance in terms of pi around your circle. So the question then became what an actual radian is, and to demonstrate that I need my coffee filter one, so hang on. So once we had the radius, we started at 0, and you're trying to wrap it around, curve it around, oh, can somebody grab that? Wrap it around so that you get the radius distance curved around your circle. Yes. Right up here. So the curved distance around a circle that is equal to the length of the radius. We'll get to it. I'd say it kind of, it will vary depending on what the radius is, but the way that we use it doesn't change. Pause, because a lot of people are still writing, so they can't listen while they write. So, no matter how big your radius is, like you could have a circle with a 20-foot radius, you're going to be able to wrap that radius around the circle hopefully what you guys discovered, but you may or may not have, and I didn't finish mine. Oh yeah, I did. So if I look at, and I'll move this in just a minute. So if I look at my points that I wrapped around, so they had us label P1, I wrapped it around again, P2, P3, P4, P5, and P6. So I was able to wrap it around 6 times and then a little bit more. So that little bit more should correspond to approximately 6.28, which is approximately equal to what? 2 pi. So no matter what your radius is, it will wrap around that circle 2 pi times. And that's the ratio pi. That's where it comes from. So, when we're looking at how to do those conversions, I don't even remember where I left off. I was recording that whole thing. Oh well. So, when I'm looking at conversions, it has to do completely with the distance around the circle. So, one thing you want to make sure you're aware of, so if I look at 30 degrees, the 30 degrees is actually referring to this interior angle right here, this central angle. The radian, pi over 6, the distance in radians, is actually this curved distance of the circle right here. So, when I'm converting between the two, it has everything to do with the fraction of the circle that I'm dealing with. So if I have 30 degrees, so I'm going to go degrees to radians right now. Again, you should be writing this down. So I already know that the 30 degrees is pi over 6 radians, but I want to show you guys how that actually works. So 30 degrees is what fraction of the entire circle? If I take my 30 out of my 360, that's going to give me the fraction of the whole circle. So to convert it to radians, what is a whole circle in radians? 2 pi. So you apply that fraction to 2 pi. So that's going to give me 30 over 360 is 1/12 times 2 pi. So I'm just going to put the 2 pi on the top, which reduces to 1/6 pi, or pi over 6, which we already know from our unit circle. But how can we generalize that formula? Yep. So degrees divided by 360 multiplied by 2 pi is going to give us our radians. We can also, can we reduce that formula, the 2 pi over 360? Yeah. So 2 and 360 are both divisible by 2, so this can be degrees times pi divided by 180. And generally speaking, we're going to leave things in terms of pi. How do you suppose we'll go backwards from radians to degrees? Say again? Yep. So radians times 180 divided by pi. Basically just the inverse of this. And that is pretty much what you needed to get out of 5-2. Some of you got there and some of you had a much harder time with it, and that's fine, but that's why we're wrapping it all up now. We are going to add to this unit circle as we go along, and you guys will, if your coffee filter one is a mess, don't worry, we'll get other ones at some point. But it's really, really important in knowing what those numbers are to be able to look at it in terms of what fraction of the circle you're dealing with. All right, so that is that.